Good morning, my YouTube viewers. Crystal here. I decided to go ahead and make another video in the middle of the night because last night around 10 o'clock, I'm not sure exactly the time, but it was in the evening, we received communication from Boris Johnson that said that we're going into another lockdown, and he gave the reasons for the lockdown. So I thought about it. Well, this is our third lockdown in 10 months. And so I thought about it and I thought, well, just in case anybody doesn't know the reasons for the lockdown, I thought I'd make a video on a data scientist perspective on why the UK has gone into lockdown for the third time in 10 months. And the best way to talk about this perspective is to actually look at the data that we have on this data set that's updated every single day. I'm waiting for the data to be updated this morning so I can make a blog post. But until I make the blog post, I can go ahead and make a video on the existing data. And then when the new data is updated, then I can work on the blog post. So the first thing that we did is we used this data from a website called Our World in Data. And what that does is that gives you the most current coronavirus, COVID-19 data, which is updated every single day. And then you have to read the data into a file. But the first thing we did was we created a program. We created this program on Google Colab, which is a free online Jupyter notebook that you can use. I recently found out yesterday that they have a Google Colab Pro that you can pay $9.99 for to get a lot more Google power. But of course, I haven't got $9.99 to do that. And a lot of people don't have $9.99 to do that. But if you want more power, then you can always use Google Colab Pro. And of course, Google's not paying me to endorse their products. So I just use Google Colab, which is free. And another alternative is if you need a lot of power, I think you can use the Kaggle Jupyter notebook, and you get like 4 hours of TensorFlow a week if you need it. But I don't really use TensorFlow. I don't make programs that require a lot of memories, but I am going to try to make more programs and do more things. But I'm going to try to do more things that don't take a lot of memory because I haven't got a lot of memory on my computer, as a lot of people just starting out don't either. So we got this data set that's updated every day, and so we read it into our program, but it's like 57,992 rows at the moment. So that's a lot of rows to go through. And the reason why is they have 191 or 192 countries that they're analyzing, and they give data for every single day. So we've had this virus going for 11 months now. So it's been collecting data for 11 months every day for 191 or 192 countries. So we go through, we look at the info. You see the info. The info says we've got mostly floats and a few objects, which is good because floats are numeric, and numeric columns are easier to work with than object columns, because object columns, you either have to drop them or convert them to numeric. So now what we've done is we've imported our date time, where what we've done is we've actually converted our date to numeric, which is one thing that we have to do. And so you go to the very end here, and you can see that our date has been converted to numeric. We created a new column, which is numeric, which is good. So now what you want to do is you want to see how many countries that this data set is analyzing. And so what we do is we make a list. And that you can probably do this for other things as well. If you ever have a column that's got a lot of data in it, then you can use this code to make a list to get the column of the data. So that's a good idea. And then we make a list, and what we do is if a country is not already in the list, then it will be appended to the list. So that's how they do it. And there's currently 192 countries in this list, but one of the countries must have dropped out because, like, whenever I do my analysis, it's only 191 countries. So one country has dropped out. I don't know which country that is. Okay, so now what we do is we manipulate the date because we want to be able to select which date that we're analyzing. So we want to select today's date. So it says today is the 4th of January 21. And then yesterday's date was the 3rd of January 21. The last date, that's the maximum date in the file, is 3rd of January 21. And yes, let me see what it says. And now what we do is we're doing an if, elif, and else code. So the last date equals yesterday. And if the last date equals yesterday, then the last date equals yesterday. Else if the last date is greater than yesterday, the last date equals yesterday. Else the last date equals last date. And then you look at last date, and then so that gives you a timestamp. So this is the last date that has been input into the system. It's 3 January 21, and it's got 191 rows, so that means 191 countries are being analyzed. So we've done a little chart using Matplotlib, do a little chart of the new cases, do a chart of the new deaths. And now what we're doing is we're doing a chart of the location so you can see how the new cases fit in with the location. So I think that United States and United Kingdom have the most cases, or they're up there. So now what we do is we do a location on the new deaths, and you can see that the United States and the United Kingdom have the most deaths. Now what we're doing is we're doing a box chart, and you can look at North America. North America has the most new cases in this box chart, followed by Asia. And you look at new deaths. North America has the most consistent new deaths in this box chart. Now we have a heat map. If you like heat maps and you want to analyze the heat map, well, we've got a heat map right here where you can got lots of columns to analyze. So now what we're doing is we're looking at the United Kingdom, and so we filtered out the United Kingdom from every column, we filtered out the United Kingdom from the main data set, and you can see that the last state we have is 3 January 21, and I'm waiting for the data frame to be updated so I can run it again on the most current date. But so we say that the new cases was 55,157. So that was a lot. New deaths was 455. So that was a lot. So they have lots of statistics that you can enter in there, but it's not being entered into this website. So they have ICU patients, they haven't given that information. Hospital patients, they haven't given that information. Weekly ICU admission, they haven't given that information. Weekly hospital admissions, they haven't given that information. And then so they talk about new tests. So they gave 492 new tests on a date. Total test, I think it's 5 million, I think. 52 million total test. Total tests per 1,000, 766. New tests per 1,000, 6.194. New tests smoothed. So the positive rate, test per case, test performed, population 67 million, almost 68 million. Population density, median age is close to 41, and so I'm older than that. Age 65 and older, age 70 and older. GDP per capita. So extreme poverty, 0.2. Cardiovascular death. Diabetes. Female smokers, male smokers. Hand washing facilities. Hospital beds per 1,000, 2.54. So life expectancy and human development index. So we know we've got hospital beds per 1,000 is 2.54, but they haven't given the information on hospital admissions. So we look at the chart of the new cases, and you can see that the new cases are going up. So, and that's because they're doing more testing, but it's also because we have a new strain of COVID-19 coming out of the UK that is a lot more infectious than the previous strain. So you can look here at the beginning of the pandemic. We started getting a lot of cases, and so we went into a lockdown to try to isolate the virus, because we thought, well, if we stay inside, the virus isn't going to have anywhere to go, so it'll just die. But that's not what happened. And then so we had the first lockdown, and when we had the first lockdown, it still wasn't a lot. We didn't have as many cases as we had previously. But then what happened was, during the summer, we had the summer and everything was okay in the summer. But what happened was, this new strain coming out of the UK developed, and it was a lot more infectious than the initial virus that we got. And because it was a lot more infectious than the initial virus, it's a lot easier for people to actually catch the COVID-19. And as a result of that, we went into a second lockdown. We went into a second lockdown from November to December. And it decreased the cases a little bit, but not a lot. And then after we had the lockdown, we went into the tier system. And so we originally had a 3-tier system, and then we went into a 4-tier system. So we were in a 4-tier system. And then you can see that even when we're in a 3-tier system and a 4-tier system, you can see that the cases are going up. And so last night we received communication from Boris Johnson, our Prime Minister, saying that we have to go into yet another lockdown. And so that's why we have to go into a lockdown, because of this new virulent strain of the virus that is a lot more infectious. I think they say it's like 70% more infectious than the original virus, and that's why we're going into lockdown. And they're saying that specifically the reason why we're going into lockdown is because, obviously it's going to cripple the medical system, because in the UK the medical system is part of the government, and so that's why. And obviously because this is a scientific um, video, I have to sort of like refrain from saying a lot of things that I feel. But they had this lockdown to save the NHS because this virus is just having a very detrimental impact on the hospitals, and that's really the only thing I can say about it on video. And now we're looking at the new deaths, and you can see here that when this is the new deaths per million, and you can see here that we got our new deaths. And so again, at the beginning of the virus over here in March, when we had our first lockdown, we had a lot of deaths, and then they were able to get the deaths under control. They were able to find new treatments for people, tell people to wear masks, and tell people to wash their hands, because cleanliness plays a big part in this virus, because it latches onto things. It latches onto your clothes, it latches onto your hands, it latches onto napkins, pieces of paper, it latches onto just about everything. And so with more cleanliness, there's more possibility that you're not going to get the virus. And so in the summer we were doing okay. We were developing new treatments, getting more ventilators, using our mask. But then things started creeping up, and they've started creeping up, and the deaths are not quite at the level that they were at in April, but it's getting close, which is why we had to have another lockdown. So let's just compare the U.S. What we're going to do is we're going to compare the U.S. deaths per million. So the UK, you had new cases 55,000 and new deaths 455. So let's look at the US. You had 210,000 new cases and 1,394. So the US had more. And let's look at their hospital beds, because that's one piece of information that is on this data set for the UK. So the median age in the US is 38, which is about 3 years younger than the UK. Extreme poverty, it looks like it's more than the UK. Hospital beds per 1,000 is 2.77. Let's go back and look at the UK's hospital beds per 1,000, because that's really revealing. That's 2.54 in the UK, hospital beds per 1,000, as opposed to 2.77. So in the US, you have more just slightly more hospital beds per thousand than you do in the UK. But in the US, it's different because in the US, you have to have health insurance, which a lot of people lost their health insurance in the pandemic. So we'll look at the US's new cases and new deaths, and they're similar to the UK's. Now we look at China. It's not really worth looking at China's because their readings are they're very secretive. We'll just put it that way. I don't want to say anything critical. I'll just say they're very secretive. But we can look and see hospital beds per thousand. Medium age is 38, same as the US. Extreme poverty looks like it's less than the US's. Hospital beds per thousand, 4.34. So they have more hospital beds per thousand than the US and the UK. Look at that. And then but their statistics, they're very secretive about their statistics. So it's not really a whole lot of point in looking at their statistics. But we can look at Taiwan. We can compare Taiwan because Taiwan is a country close to China that the World Health Organization doesn't recognize Taiwan. So they had new cases is 4. That's quite low. And new deaths is 0. That's really low. And what we'll do is we'll just look at some more information. And some of these countries don't provide information about their hospital, about admissions to the hospital and things like that. Because they don't provide information about admission to the hospital, then it's difficult. Population looks like 23 million. Median age is 42, so the median age is older than it is in the US and the UK. Hospital beds per thousand, they didn't give that information. And then so that's one of the problems with this data set, that they're not giving all the information. They give some information, but they don't give all of the information. So it makes it difficult to predict because they don't give all of the information. So now Taiwan is saying they don't have any deaths for COVID-19. They're saying because Taiwan is a democratic country, mainstream media is saying that they don't have very many new cases and very many new deaths because they took action immediately to tackle the disease in their country. And they're really clean and they wear masks. And they also, like people who are in isolation, they give them a certain amount of money for every day that they're in isolation. And then they have people bring them food, which we don't get that in the UK. We don't get that at all. So now what we'll do is we'll look at Japan, because Japan is a country that I wanted to look at, because Japan is saying that they're going to go into a state of emergency because their cases of coronavirus has crept up. So we can look at Japan. So we have 3,196 new cases. So that's about 16, 17 times less than the UK, but they're saying this is a state of emergency. And we have 60 new deaths, which is a lot less than the UK. But they're still saying it's a state of emergency because they are not accustomed to having that many new cases and that many new deaths. So we can look over here. Their population looks like 126 million. Median age is 48, so the median age in Japan is higher than the median age in the US and the UK. So that's interesting. So it says hospital beds per 1,000, so that's 13 hospital beds per 1,000. So they have significantly more hospital beds per 1,000 than they do in the US and the UK. And that probably has something to do with why they don't have as many deaths, so that's very interesting information. And you can see, we can look at Japan. Although Japan has a lot less cases than the US and the UK, you can see that Japan is following a similar route that the UK is following, whereas this new strain of the virus is like a lot more infectious, and because it's a lot more infectious, their cases are creeping up and their deaths are creeping up as well. And so that's why Japan says that they want to have a state of emergency. But what we'll do is we'll go down. We won't look at any more of the countries that I've been analyzing, because it's all just more of the same, really. And so what we've done here is we've put it on a chart, like the new cases per million to the new deaths per million, and you can see the new deaths per million are a lot less than the new cases per million. You can see that on the chart, and you can see that we're looking at the US. So the new cases per million are a lot more than the new deaths per million, but you can see that the cases are creeping up, and this is to do with that more infectious strain of the virus. And it's the same thing with the UK. The new cases per million are a lot more than the new deaths per million, but it's still creeping up. It's still creeping up there, and it's to do with this new strain. So now what we're doing is we're comparing the countries, and then so we have to make sure that all the countries analyzed have the same amount of rows and columns. So I had to remove some rows to make all of the make all of the data frames compatible. So now that you know what I've done in that regard, I'll just skip through that. And then now, because we're going to make a new data frame that's got all of this information on it, so what we have to do is we had to define variables for the new data frame. And one thing we had to do was we had to define a date, but you have to use the values of the date. You can't use the actual date, just the values of the date. And so now what we've done is we've created a data frame for every country that we want to analyze. And we've merged all these data frames together to make one big data frame, and then we've checked for any null values. And since all of the null values are in numeric columns, then what we're going to do is we're just going to fill it with 0. We're going to fill all the null values with 0. So now what we've done is, the most recent thing I've done is I've checked Japan, because Japan has a low amount of cases. So you can look at the new cases and you can compare the UK's new cases with Japan's new cases. And so Japan's new cases are a lot smaller than the UK's new cases, but you can still see on the graph that it's creeping up. And it's the same thing with the new deaths. Japan's new deaths are a lot smaller than the UK's new deaths, but you can see that it's creeping up. And so that's why we've had the UK, if you compare the UK to Japan, you can see like how Japan is tackling this problem opposed to the UK is tackling the problem. And it's not really the UK's fault, because what has happened is this virus has mutated. And because the virus is mutating, it's a lot more infectious and it's a lot easier for people to actually get the disease. And we've already looked to see that Japan has a lot more hospital beds than the UK and the US. And so that's going to have a lot to do with it, because if they haven't got hospital beds, they can't treat people. And that's another reason why we had to have a lockdown, because the NHS just couldn't cope with the influx of people who have become ill from the virus. And obviously, I have to be careful what I say in that regard, but this is just common knowledge, so I'm not saying anything that's not common knowledge. So that's it, really. I think that one of the factors that's causing the UK to have so many deaths in particular is because they have a lot less hospital beds than they do in Japan. And since they have a lot less hospital beds, if people are sick from the virus, well, what are they going to do? So that would be one thing that the UK could do to reduce the number of deaths, as to get more hospital beds. And I do think that they have gotten more hospital beds, because they had this special Nightingale Hospital, and they're going to open up the Nightingale Hospital for people who are sick from the virus. So that's one thing that they can do. And there are a lot of political ramifications for this as well, because in the UK, the hospitals are run by the government, and so obviously the government, we're in austerity, and because we're in austerity, they are making cuts here, there, and everywhere else. And one of the places where they were making cuts was NHS, and so NHS would have to make cuts as well. And so hospital beds and the treatment that they give would have something to do with that. And I know from my personal experience that they've made cuts, because I have a skin condition and they no longer treat that skin condition. So, and I've had other experiences going to the hospital where I wasn't treated. And so the government just makes all these cuts, and they just say, well, we're not going to treat this, we're not going to treat that, we're not going to treat lots of things. And because the NHS has lost funding to treat certain things, then obviously people aren't getting the optimum medical treatment. So that's one problem we've got, just from a data scientist perspective, and someone who's actually living in the UK and knows what the UK system is like. So the next thing we do is we've already compared the UK against Japan, which I had been intending to do that, but I'm always thinking, well, what can I make a video on? But now what we're doing is we're going back to the main data frame, and we're checking null values on the main data frame. And so we've got lots of null values. And so what we wanted to do was we wanted to delete the date, because the date is a timestamp, and you're not going to be able to put a timestamp in the model. So, and another thing we want to do is we want to separate out the object files from the numeric files, so you can see all the object files. And what I've done in the to impute these object columns, then what we've done is we just said anything that's a null value, you just put in there, not listed. I made the decision not to put the most commonly used value in there, because we don't know what it is. And to be more honest, just to say not listed. And so since we have imputed all of the categorical columns, now all we have to do is in the train file, just fill it with 0. you know. Now what we've done is we've taken all of the categorical columns and we put them on an ordinal encoder. And when you put it on an ordinal encoder, what you're doing is you're converting every category to a numeric sequence. Now we've defined our X and Y values. So our Y is new death, and we've got our X is our train, but we dropped a lot of columns in that regard. And now we've got our standard scalar, so we put our X column under a standard scalar. Now what we want to do is we want to take our X variable and we want to convert it to, we want to break it down for training and testing using the train test split function in sklearn, and our test size is going to be 10%. Now we've used our model, so we decided that we're going to use the His gradient boost regressor because that's a model that has been designed for large data sets, and this is a large data set, and so we have 99.42% accuracy when we train it, and then when we predict on the validation set, we have 90.46% accuracy, which is still good. So we've made a little chart so you can check out the predicted values against the actual values, and you can see that they're pretty close. And then, so what we're doing now is we're creating our test data set so we can test. So test equals last date, which we've already made, and test date equals today and end the test. So you can see that, and we've already done that. And then what we have to do is we have to convert the date to a number. So we use code to convert the date to the number, and you can see here in the final column, the date has been converted to a number. Then what we have to do is we have to check the null values just like we did in the training data set. And we have to deal with the null values in the exact same way that we dealt with them in the training data set by putting not listed on all the null values in the categorical columns. And when you've done that, you can replace all of the null values in the numeric columns with 0. So now we've got our new test. Put it on ordinal encoder, so all of the categorical columns are ordinal encoded, given a numeric value. And what we do now is we define our X test, and X test is defined in exactly the same manner that X is defined. We put an X test on a standard scalar, and we predict on the X test for the next day. And so if you wanted to, you could take your predictions and you could compare them against the actual values and see what the result was going to be. So you could do that if you wanted to. So that concludes this program, and you can see what we've done is we showed you the program that we made, and then we decided from a data scientist perspective on why the UK has gone into lockdown. So we'll be making a blog post on this, but I'm not going to do the blog post until the data set is updated in a few hours. And then when the data set is updated in a few hours, I'll have the most current information, which means I'll be able to run the program, and then I'll be able to download it and save it onto GitHub, and then use GitHub to make the blog post. But when I do the blog post, I'm just going to really talk about the graphics part of it. I'm not going to talk about the what I actually did to get to the graphics part, because I've done that in the past. So that concludes it for our video for today. If you like my video, please like, subscribe, and share. If you want to see more videos, please hit the bell button. And I was watching a YouTube video or listening to a YouTube video, and they said that if you don't watch the videos, then what happens is YouTube will unsubscribe you from that channel. So if you want to stay subscribed, then you need to watch the videos so you can stay subscribed. So if you hit the bell button, you will get a notification every time I make a video. And so also, if you like the work I do and you want to make a donation, I have my email address to my PayPal account in the description box down below, because I don't have enough subscribers, so I can't monetize, and the only way that I can make any money on this channel is to, one, ask for donations, or two, people to read my blog posts. So if you read my blog posts, that's one way that you can help me make money without you actually having to spend any money. So thank you so much for watching this video, and I look forward to making other videos for you in the future.